Hello everybody, welcome to my channel. Today we will see about multi-trait stability index in our software using Metan package. As all of you know that multiple environmental trait analysis performed considering only single trait gradient, yeah. And the reliability of recommending genotype nowadays increased when several traits are considered. And there are a number of methods proposed for the multiple environmental trait analysis that combines simultaneous selection for the stability of several traits into a single and easy way. Among this one is WASAP, as you can see here. That means the weighted average of absolute score. And the genotype with the lowest value is considered the most stable genotype among the given genotypes. So let's submit this one, the methane package, and again we will use the data underscore G2 for this tutorial. And as you can see, here is the data. It is composed of 156 rows and 18 columns. Here is the environment, here is the genotype, replication, and starting from column 4 up to the end are the agronomic trait. And if you are interested about the data, yes, you just type this data underscore then G2, then you will get information here. And let's see together, it is a multi-trail of maize. Yes, it is 15 traits assessed in 13 maize hybrids growing in four environment. Experimental design was RCBD with 3 blocks and 1 application per block. Yeah, so this by this way you can get detailed information regarding the response variable trait, agronomic trait, the method and experimental design, and the genotype. So let's create some model here. I assigned X is capital X. You can give any name that you want. Then you have to use a function. Here is WASAP B is a function that helps us to create the model, and immediately you have to tell to R your data name. So our data name for sake of this tutorial is data underscore G2, then followed by in gen rep and response variable. That means environment, you have to indicate the column that containing the column name that containing the environment. Again, the column name that contains the genotype, and the replication that contain the column that contains the replication name. So environment gen rep, which is found in our data, so you have to specify in this way and provide the code to R. Then response variable, here is for some traits. Previously or traditionally, most of the time, the multiple environmental trait analysis rely only on grain yield or maybe some yield component. So if you are interested for some particular or for some trait, you can specify recipe means it is a response variable or the agronomic trait under study. So you have to use this function. This NK is the number of kernel per year, 1000 kernel weight, and again EL is ear length since the crop is maize. So you can specify for some trait in this way. I'll show you if you want to select all traits that you have in your data later. So type this and send it to our studio. Then our aim is to select by considering 3 agronomic traits and which genotype is stable. So to do that, you have to use MTSI, which stands for multi-trait stability index. So as I mentioned before, the lowest stability or the lowest MTSI or WASAP is considered as the most stable. Then you can give any name that you want here, but I give here is MTSI underscore index. Then X is what we created with WASAP. Then the index is here again is WASAP. Then you can get this result on the base of NKE, TKW, and ear length. That means number of kernel per ear, 1000 kernel weight, as well as the ear length on this selection, on these traits, genotype 10 and genotype or hybrid 10 and hybrid 11 is selected. Again, if you are interested to display this in a graphical approach, you have to use the function plot, then immediately provide this name, what we created here. So accordingly, here is the one that marked with red are selected, but the black is not selected. So genotype 11 and genotype 10 are selected. Even here is genotype 10 and genotype 11, or hybrid 10 and hybrid 11 are selected. So you can display a graphical approach in this way. Moreover, if you want to get the exact magnitude, so put this one and you will get this result. So the lowest as compared to all these values here is 0.48, 0.408 and 0.304, which is designated for genotype 11 and genotype 10 are selected. So the graphical approach is better. Yeah, let's continue. If you are interested for all traits, that means we have around 18 columns, 1, 2, 3, 4. When we discard the 3, it's 15. So if you are interested for 15 traits, so you have to specify all things the same. You provide the data, and I change the name from X to Y. Again, I display the environment, genotype, replication, and instead of explaining or instead of displaying some traits like you did before, like this, you have to specify everything. So R will consider all the response variable or agronomic trait under study will be evaluated for the stable genotype to be selected. Yeah. Then I changed this into 2. The previous one is MTSI underscore index. Then change X into Y here. And you can give any name that you want. You can Z, or you can give your name or your site, whatever it is. Then type this. This is ANOVA. Don't confuse with ANOVA. Don't confuse with this one. Then go for the plot. Okay, this one. Oh, sorry, we forget to create this one. Yeah. So on the basis of all response variables or all agronomic traits, genotype 11 and genotype 5 or hybrid 11 and hybrid 5 are selected. Let's display this in the graph. Yeah. Yes, genotype or hybrid 5 and 11 are selected. If you're interested in the magnitude value, do this. Then you'll get this result. Yeah. So the lowest value is the lowest value is the most stable one. So by this way, we can compute a multi-trait stability index in our software. Thank you for watching. Have a nice time.